Let's discuss a question from machine design. A plate clutch is given which supports the axial load of okay. So this R1 is the, let's say, the min radius, and R2 is the max radius. Now the total load is 4500 Newton, and the inner radius is 50 mm. The outer radius is 100 mm. The ratio of maximum to the minimum pressure. Now remember that in uniform wear, well, the basic assumption which uniform wear starts is that generally at higher at 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 the periphery, at the circumference periphery, actually it loses material first, and that's what happens is that there is no material contact at the outer periphery. It loses because of the higher velocity. Now v is r omega if it is rotating with one constant speed, so v will be larger at higher at, at the periphery, and that erodes because the more relative speed will be there between two disks at the periphery, and that, so it loses material, starts eroding, material starts eroding at the outer surface first, and therefore the total load will be mostly supported mostly at the inner surface. Okay, so uniform wear starts with the relation that PR is constant. Higher pressure is supported at the lower radius. The intensity of pressure is maximum at the lower radius. So going by this, P1 R1 is P2 R2, and the max pressure happens at R mean, and the minimum pressure happens at R max. Now this is just a model. So what is R is P max by P mean is R's. Yeah, and that is P max by P min is R min by R max. R min is 50, R max is 100, so this is 1 by 2. So you need not actually solve the problem if you understand what is the basic background of uniform wear theory. So the answer is P max by P min. P max, sorry, I think there is a mistake. What we did was, it should be max here, R max by R mean. So R max is 100 by 50, this is 2, obviously, I mean, so there's a silly mistake. So this answer is 2, P max by P min. So if you understand this basic equation, the basic background of uniform wear theory, you should be able to solve anything. So the answer is 2, and you need not solve the problem. I mean, you can do it, but it will take time. Okay, but from the basic assumption of uniform wear, you should be able to tell the answer directly. It's in the inverse ratio of their radius. Thank you.